The principle of electric motors is so simple. Anyone who graduated from elementary school knows that magnets repel at the same pole and attract at different poles. So if we put a small hole in the center of the first magnet, then we put a shaft through the hole so that it can rotate freely. At this point, when the second magnet is close to it with the same pole, it will rotate around the shaft. After half a revolution, we switch the poles of the second magnet, and so on and so forth. The first magnet will keep rotating because the poles are repulsive. Similarly, a bolt wrapped in insulated wire becomes an electromagnet when it's energized. A hole is drilled in the center of this electromagnet and a shaft is threaded through it. Can be used to replace the first magnet. The effect is exactly the same, but the electromagnet has an advantage. It allows us to change the magnetic poles by switching the direction of the current. But it's too much trouble to switch the wires, so we can bend the magnets on both sides. Instead of a winding bolt in the center, we can use a metal circuit, an armature. The armature will rotate when it's energized. At this point, we can remove the wires from the armature and replace them with two curved pieces of metal. The two slits in the center have the effect of changing the direction of the current. So these two pieces are called commutators. Then on both sides of the commutator, we put brushes that have good contact with the commutator. So the armature can also rotate when the brushes are energized, but with the commutator and the brushes. When the brushes pass through the gap of the commutator, the direction of current can be switched automatically. So the armature can keep rotating automatically, but the armature will feel stuck when it passes through the gap. But when you add more armatures and more commutators, it doesn't feel like it's lagging anymore. And then finally, you fix all the armatures together as a single unit, and it becomes our usual motor.